Statistics world over are kind of indicating that AI is past the hype cycle, getting into mainstream implementation. But at the same time, there is increasing wariness of deploying AI in mission critical applications. Primarily, the reports which are coming from the field are pointing to several accidents which are happening in the field of AI. And when we started to chronicle these AI accidents, it was eye-opening. It is deployed and is programmed to take in, human input so that it understands what humans want to interact with and provides a feedback to how it should look at the different inputs provided by humans and try to respond. So, with a view to that, it offered a way to accept human inputs. But so happened that in some cases, such kind of bots requiring human inputs were fed poisonous inputs. Like in one case, like the Microsoft A, it was poisoned with racist comments, and that led to company having to withdraw such a tool. Then we also found some of the market surveys which said that about 76% of the CXOs are not very happy about AI when it comes to answering business decisions, especially with respect to interpretability or biases or fairness. And that's not a very acceptable solution. So when we started looking at these accidents,
You might be wondering why all the AI problems are happening. Why is it that people do not trust AI? And the answer to that is very simple: non standard, non rigorous testing. We are still testing in a randomized fashion. So, how do existing testing techniques lack? Well, very quickly, I can tell you that lack of testing from a perspective of bias, lack of explainability, randomized testing, too much focus on metrics without really focusing on the larger picture, and lack of techniques or rigor for testing for privacy, adversarial attacks, and so on. On top, lack of Oracle causes bigger problems.
so whether you take both cases, whether it's fairness violation, whether it is poisoning of the model with the nefarious content, it's definitely not the best of the world for AI deployment. That said and done, it's not that we're only seeing fairness and poisoning kind of attacks. There are several other issues with today's AI deployments. In some cases, we have seen some maybe not so small but quite fatal accidents, like the Uber accident in which there was a loss of human life. So, the range of accidents has been from simple mistaken identity to poisoning of content to fairness violations to loss of life. But why do all these accidents happen? Why is it that 76% of CEOs are not happy with the fairness and transparency of current AI models? The answer lies in non-rigorous testing. So when I say non-rigorous testing, the question comes, do current AI models not get tested? Yes, they do get tested by data scientist teams. There are randomized testing algorithms for AI testing. But are they sufficient? Maybe not. Current data science process of testing maybe are good enough for handling, at best, a probabilistic approximation of the reality and the scenarios. So in that sense, there is quite often possibility that they will not be specifically looking for scenarios which are violating fairness or scenarios which are security violations via poisoning of attacks or maybe extreme corner cases. So what's the substitute? The answer lies in what we call as a comprehensive end-to-end AI testing platform. So when I say AI end-to-end testing platform, what are the constituents of such a platform? And we answer that by offering these as the features in our product AIEnsured. So if you look at the goal of AIEnsured, it is to provide a comprehensive testing platform for AI solutions to overcome the gaps between current deployments and to-be deployments, which we can assure that there will be lesser accidents and fewer cases of withdrawal, and overall performance of AI models being better and more accurate. So what are these dimensions of testing? Let's say we start with the notion of coverage. Coverage, especially in the classic testing parlance, refers to out of the all possible real life scenarios of inputs, how much of the real inputs are getting addressed correctly, or is the system functioning correctly for the different input real scenarios. So unfortunately, in terms of ensuring coverage in AI models, there is a problem. The problem is in AI models, we don't have a oracle. Oracle means any system which you're testing will actually have a proper expected output, which you can compare with the gold standard and give a report. It's matching, it's not matching. So you can give a report, how many test cases have passed, how many have failed. But in case of AI, when your output of feeding the data is a non-deterministic model, right, which is approximating the pattern in the data, we're not assured of there is a gold standard. This is the perfect model. This is the perfect, answer to the fitting of the patterns in the model. There can be millions of such patterns. But what we try to do is we try to approximate by metrics like accuracy. But even in that case, we are not actually talking about any perfect oracle. So what we do is, in place of a conventional notion of test oracle, we face the issue of what we call as how to build a sufficiently accurate oracle. So with that in mind, we take two perspectives for bringing testing coverage notions into the AI testing world. One, we call it metamorphic testing or pseudo-oracle. In metamorphic testing, the idea is very simple. Instead of testing the expected output and comparing it with the gold standard output, we just try to look at whether the relation which was supposed to be between the input and the output, if you transform the input, is also maintaining the relation between the output of the transformed input. So in that sense, we try to look at metamorphic relations, which talk about the relation between input, output, transformed input and transformed output. It could be in different kinds of relations, but the idea is you're not testing the real oracle, like comparing expected output and real output, but instead we're tracking some relations between the four of these. So to give an example, let's say we have an image classifier, which suppose is around 95% accurate for the original input data in which you're trained. But now, one of the metamorphic relation we can try is, suppose we just rotate the images, all the images which we have used for training data, in a small angle, let's say 10 degrees, 15 degrees. And we see is the model giving similar accuracies for these transformed images. If actually for certain rotations, it's not giving similar accuracies, suppose it's giving very low accuracy compared to the 95%. That means the input which has been used to train this model has not been considered for that kind of rotation. So that metamorphic testing is allowing us to find what we call as corner cases. Corner cases in that will be, so let's say the 15% rotation is giving very less accuracy. So we say the images which are 15% rotated from the original are some things which are not considered in the original training data. So that's why we had to start trying including more of that in the training data to improve the model. So that's a classic example of metamorphic testing, where you say that transformation of an image does not change the accuracy. That's the metamorphic relation we expect to hold. But if it does not hold, it means you're looking at corner case. The second approach to coverage is the notion of how well are you covering the different model structures. In case of conventional statements, if there was an if-then-else loop, you would say, okay, this set of test cases are covering this if branch, this then branch, and all the considered combinations of that. But here we use similar concept, but from a neural network perspective, we try to traverse the paths and see what percentage of paths are covered, and we try to uncover corner cases by finding those paths which are not adequately covered and deriving the corresponding examples or training data. So what happens is we can detect corner cases by finding out those paths are not covered. So both the white box and the metamorphic testing approaches are meant to bring testing concepts to add coverage to AI testing. So that's the first aspect. The second aspect, which is also a very critical element of any IT system, is the security. If you look at security today, the security is about, can you create a robust system which is foolproof against hackers? So today, if you look at a web-based system, when you kind of deploy, before we deploy, you try to test it for any possible attacks by either SQL injection or some kind of a, any kind of a cross-site scripting, different kinds of attacks, right? You try to look at that and see if your scripts and all are not, opening any holes for hackers. But unfortunately, the attack vectors which are coming in the AI domain are new, and they're coming up with perturbing images with certain kind of transformation and attacks on the images so that they can fool the AI models. So we have to actually bring security testing into AI testing perspective by looking at applying different transformations which are basically the attack vectors on the images, and try to see if we can find out those corner cases based on attack vectors applied on the input training data. The purpose of it is very simple. If you know the attack vectors, you can make the model be prepared for these attack vectors ahead by training the model with these attack vectors in mind. Otherwise, think about it. If you are having a security attack and you're not tested your model for security and you're deploying it, you're actually leaving an insecure model prone to hackers' attacks anytime. And that's why security testing is the next important thing. The next dimension is the concept of what we call as privacy testing. And privacy testing is in its nascent stages of AI models, where we're talking about potentially data being leaked from models after being subject to some privacy attacks and possibly having some lacunae in the anonymization or any way of technique where you're trying to pass on the PII without anonymization into the models. So privacy testing is going to help you detect if any data is leaked into the model, and if any of that is actually going to be leaking a PII, which is a sure shot cause for, violation of compliance, and then we may face the issue of having to stop the model. The fourth dimension, which is also very important, is the concept of fairness. We saw the AI accidents which are caused about unfair models which have to be deployed and then redeployed after having taken into account the fairness concept. So fairness testing tests for whether the model is actually displaying fairness, or is it biased to certain aspects of the input data like gender or age, etc. So we have to test for fairness, which is an important part of the AI models. So having said that, we looked at the critical aspects like security, privacy, we looked at fairness, then we looked at the aspect of coverage. The next important aspect is this whole notion of explainability. In explainability, we look at either black box or white box explainability, and it's a post facto technique for after your model has taken a decision and you find some places it's taken a wrong decision, you try to go to the root cause and find out what part of the data is responsible for such a decision. And then last but not the least, we are also talking about testing a model for performance. Performance is a basic national non-functional requirements as per ISO standards. So what we want to look at is the model performing as per expected? For example, if suppose a fraud detection algorithm is supposed to hundreds of thousands of users per second, and it's only provisioned for 1,000 users, then it's definitely bound to be non-performant, right? So we have to do performance testing of AI models. And while performance testing for static models is a good thing, we also want to look at, can we create a model testing for performance even in a scenario of concept drift. Concept drift talks about drifting away of the accuracies of the models as time passes by. So over regular intervals of time, can you test for performance of the models at regular intervals and identify testing for concept drift, so that if there's a significant drift, we can go back and retrain the model. So as we said, we're talking about the different aspects of security testing, and finally, we also talk about several scenarios where the cause of improper behavior or maybe not so accurate behavior of models is lack of sufficient data. So we also need to provide for sufficient data adequacy for the AI models. So we have to work on example techniques for generation of sufficient test data or training data for AI models. So data adequacy is another horizontal dimension which our product works on. All said and done, these models are great. This testing of these different techniques are good. But what use is a test report which comes out from this tool for the developers and data scientists and testers. The use is that now, looking at the corner cases detected by our model, we can do a feedback loop by retraining the model for correcting its security attacks, for correcting its corner cases, for correcting its fairness issues, and then the resultant model in the feedback loop after you retrain will be more robust with respect to security, with respect to corner cases, thereby improving accuracy. And last but not the least, we will be providing something which can be subject to scrutiny of fairness and come out with flying colors. So having said that, all we can say is we are improving the overall robustness and quality of the model, increasing its metrics like accuracy, making it less accident prone, making it secure, and identifying potential privacy leaks, etc., before compliance inspectors come and bring it down. So we can say we are handling both risk as well as quality related advantages to the AI model, thereby increasing its accessibility, increase its marketability, and overall bringing efficiency into the whole life cycle. So that's why we are here to bring revolution to the world of AI by bringing testing for risk and quality at the center and bringing a possibility of deploying a more trusted and fair AI model in the end. Okay, I'll add a couple of more. Hi, welcome to the world of AIEnsured, our marquee product for AI testing and quality assurance. Today, AI is at the center of digital transformation for enterprises. AI is being adopted by all verticals, right from finance to government to retail to healthcare. But unfortunately, there are several showstoppers in the world of AI, right from several accidents, including loss of lives or incidents of withdrawal of AI projects. The primary root cause of withdrawal of these AI projects or AI accidents is lack of end-to-end rigorous testing. Though there is current randomized testing process in AI lifecycle, they do not ensure the discovery of corner cases and testing for mission critical issues like fairness and bias, etc. We are also working on several proprietary patent pending technologies for ensuring all these tests for comprehensive AI models, right from images to text to structured data to time series to even including object detection and segmentation samples.
For AIEnsured, we made sure that we take a deep look at the process of how models are created, consumed, and in between tested. And where all can we really do all sorts of tests, both the AI tests and traditional conventional non-AI tests. And we looked at and we created techniques for doing model testing, for doing model integration testing for all the stages, starting from beginning, which is testing for the data, right from there to testing the model and using techniques based on bias and explainability and security to come up with test cases which will find corner cases. To the process where you quantize the model or integrate it as is. So both AI and non-AI tests for data pipeline, etc. And finally, when you put the model live and test it before actually making it live, but test it with live data. So we have techniques for those as well.
Our product AIEnsured saves the costs. It also helps in reducing the data bias. Also increases the product privacy. It is more robust too. Our sales strategy is to dominate AI projects in compliance-focused industries like healthcare, insurance, BFSI, where AI is used drastically.